Hi, in this video we're going to go over the key skills you need to know for functions for your GCSEs. Okay, so these are the main skills. I'm going to go through one at a time. First and most basic is substituting in values. So in each case, so we'll start with single expressions and then compound expressions. So you're given a function and then say work out something like f of 5. All you need to do here is every time you see x in here, replace it with 5. So 4x minus 3 will become 4 times 5 minus 3, which then gives you 17. Again, that can work with any function. So here we could do g of minus 1. And it'll be the same idea. Everywhere we see x, we're going to place it with minus 1. So x squared becomes minus 1 squared. It's helpful with this in brackets. So if you want to use your calculator, it'll work it out correctly. Also to remind you that you're squaring minus 1. And we should know that if you square any number, you always get a positive answer. So this will just give you 7 over 3. Again, no reason to write that as a mixed number. You're perfectly fine to leave it as the answer, because it's just a fraction. Next, we have the same thing with compound expressions. This is where you have two functions, and you're asked to work out something like fg of 5 or gg of 7. Okay, so first with fg of 5. For this, you always work from the middle. First, we're going to work out what g of 5 equals. We can just take this. G of 5 is going to be 14 take away 2 lots of 5, so 14 take away 10, which gives you 4. So we've now worked out that this g of 5 equals 4. Then we need to work out f of 4. So work out g of 5 and plug the answer into the next function on the outside, which in this case is f. F of 4, we do 2 times 4, which is 8, take away 3, giving us 5. You can do a compound function with itself. So here's gg of 7. So what we're going to do, we're going to work out g of 7, and we're going to plug that answer back into g again. So g of 7 is going to be 14, take away 2 lots of 7. That's 14 take away 14, so that is 0. We then plug that back into g, so g of 7 equals 0. We now need to work out g of 0. That will just be 14 take away 2 lots of nothing, which just gives us 14. So again, that's the most basic skill. Let's see what we can do. With substitution, sometimes we can use it in order to work out the value of an unknown. So here, we're told that f of 2 is 16, and we need to find the value of k. So we're going to plug in x as 2, because that's the number in here. So first of all, if we've got f of 2 here, I know that's going to equal 16. Okay, so that's just f of 2 there. On the right hand side, I've now got k take away 2 lots of 2. So k take away 4. And then I'm going to solve this equation in order to work out what k is. So opposite of minus 4 is plus 4, which gives us that k must be 20. This can get slightly harder if we use a compound function, but the principle applies the same. So here we are told that fg of 3 equals minus 7. So just like the previous question, or the previous example, I'm going to work out g of minus 3 first. That is going to be 12 over a times minus 3. Okay. This we can simplify down. We know if we do 12 over minus 3, that will just give us minus 4. So this will equal minus 4 over a. Okay, we've worked out that g of minus 3 is minus 4 over a. So we therefore know, if I grab this, that f of minus 4 over a must equal 7. Okay, so work out what g of minus 3 equals. That gives us this. We then plug it back into f, and we are told this must equal 7. So let's use that. So what we're now going to do, we're now going to plug in minus 4 over a into f of x. So we now have 2 lots of minus 4 over a plus 3, and that equals 7. We should clean it up and then solve that equation. So 2 lots of minus 4 over a, that will just give us minus 8 over a, plus 3 equals 7. We want to get rid of the plus 3, so opposite of plus 3 is minus 3, so this must equal 4. Then you want to work out what a equals. We have it divide by a, The opposite of dividing by a is timesing by a. So minus 8 must equal 4a. And then to get a by itself, we want to divide by this 4 here. So a equals minus 8 over 4, which is just minus 2. So again, a lot more steps involved there. Hopefully you see the idea in principle is the same as the previous example. You just plug it in, make it equal to what you know it equals, and then try and solve to find the value of either a or k. Okay, that was that skill. Next we have compound functions. This way we basically want to merge two small functions together into one bigger function. So here we have two functions f(g) of x, and the question might say, work out f(g) of x. And this works out the exact same idea as what we did a second ago when we substituted in values for compound expressions. We worked out what the inside thing equaled and then plug it into the outside thing. So here, we've got g of x on the inside and we know what that equals. That just equals 2x plus 1. So now we have f of 2x plus 1. Now we're going to plug that into f. So what this means is, everywhere you see an x here, you are going to write 2x plus 1. So the x on the top becomes 2x plus 1. Over, we then have 3x. That is now 3 lots of 2x plus 1. And then we need to add 10 to that. In order to finish this off, you expect to expand it out and have it in a slightly more simple form. So the numerator is fine as it is. We can't really change that or simplify that. We can expand out the denominator. So that now becomes 6x plus 3 plus 10. Which then takes us to our final answer, 2x plus 1 over 6x plus 13. Okay, let's see a slightly harder example. So here I've got two functions, fx and g of x. Slightly harder because here I've got a quadratic. So what we're going to work out here, just as before, is going to be f(g) of x. So first step is the same. We replace g of x with what we know it equals. Then I'm going to write f of x, I'm going to work out fx minus 1. So I write f of x again, and I replace each x with an x minus 1. So x squared becomes x minus 1 squared. 3x becomes 3 lots of x minus 1. And the plus 2 stays as it is. So here make sure you always include brackets, because x minus 1 is basically treated as a group. Now what we need to do, we need to expand all this out and simplify it. So first we have x minus 1 squared. Remember that means x minus 1 times x minus 1. And we can expand that out like so, which then gives us x squared minus 2x plus 1. So plugging that in, my first term gives me x squared minus 2x plus 1. My next term, expanding that, will give me 3x minus 3. And again the plus 2 stays as it is. Next we just group that all together. So I've got x squared, I've got minus 2x plus 3x, which is just plus x, and plus 1 minus 3 plus 2 gives me nothing. So that's my answer. So let's get rid of this. What we worked out there is we worked out the compound function f(g) of x. So that's what f(g) of x equals. Okay, next skill is doing the same compound fractions, but here with nested fractions, which basically you've got a fraction within a fraction. So the principle is exactly the same, we just have a bit of an awkward technique in the middle. So first step, we replace the inside f of x with what we know it equals. Then we're going to plug that into my original function. So everywhere I see x, rather than writing x, I have to write this stuff instead. So let's do that. We've now got 2 times 2x over x plus 3. And that is all over 2x over x plus 3. No, sorry, there should be a minus 3 there. With a minus 3 at the end. And again, just like before, we need to clean this up. So first step is going to be to expand out the brackets on the top. If we've got 2 times 2x, that will just give us 4x. Remember 2 is 2 over 1, which means my denominator will not change. And in order to sort of clean this up, what we have to do for my denominator is write this as a single fraction. So we need to find a common denominator. So again, 3, all that means is 3 over 1. So my common denominator is going to be x plus 3. And if I add an x plus 3 to the bottom, I must also add an x plus 3 to the top. So now I've got a common denominator. I can now write that as 2x, take away, I'll expand that brackets. So I've got minus 3 times x is minus 3x, and minus 3 times 3 is minus 9. Again, remember, this minus 3 is what gets times by them both, which is why they both become negative. That is all over x plus 3, x minus 3. Okay, we've got this. I can simplify up this term here. I've got 2x take away 3x. That's just going to be minus 1x or minus x. So it now looks something like this. And this is the netted fraction part. This way we've got a fraction within a fraction, and we need to know how to deal with it. The basic shortcut you can do is just realize you do these two things times together for the numerator, and these two things times together for the denominator. The reason why is that fractions mean the same thing as divisions. So I could rewrite that fraction as this, and then use normal laws of divide and fractions where you flip multiply, and this would be the end result. So skipping that step, this now equals 4x with the bottom term, x minus 3. That is my new numerator, and my denominator is these two terms times together. X minus 3 over minus x minus 9. Okay, here you're not supposed to expand. One of the main reasons is that sometimes it's really easy to see a really quick simplification. In this case, these two terms are going to cancel out. So I'm just left with 4x over minus x minus 9. And that is fine for an answer. Okay, we can simplify up the denominator. We could take out the minus sign, but we don't really need to, unless the question explicitly tells you to sort of write in a particular form. There's no real reason you need to do that. So this should be fine as an answer. Next step is finding inverse functions. Okay, so the idea behind this is you are just changing the subject of a formula. That's the way you want to think about how to do it. So let's start with this simple example. First step, we replace fx with y. Let's just make it look a wee bit nicer. Okay, that doesn't really change anything. What we're going to do, we're going to change the subject. We're going to try and get x by itself. So first step, get rid of the plus 1. Opposite of plus 1 is minus 1. Then we've got 2 times x. The opposite of timesing it by 2 is dividing it by 2. Okay, we've now changed our subject. We now have an x equals rather than y equals. That means this will now be our inverse function. So we'll then say f to the minus 1 of x is going to equal this. However, this is in terms of y. We want it in terms of x. So it'll be x minus 1 over 2. And just a quick aside, it's important to kind of aware what the inverse function does. So basically, if I worked out f of 5 in this function, that would be double 5 plus 1 is 11. If I then plugged 11 into my inverse function, if I did f to the minus 1 of 11, I would always get 5 out. So if you plug this output into the function, you will get your input. Okay, let's try a hard example. Again, using that same idea. So first step's always the same. Replace f of x with a y. And you want to rearrange to get x equals. With these questions, I'd always recommend having your x terms as positive. So I'm going to move the 2x across to the other side to make it plus 2x. Now it's fairly straightforward. Opposite of plus y is minus y. And the opposite of times by 2 is divide by 2. So now this is my inverse function. And again, we have to write it in terms of x. So rather than writing 7 minus y, we are going to write 7 minus x. Okay, I'll just do 2 more hard examples. So here the same idea, but now our x is on the bottom. So your first step stays exactly the same. And the golden rule with these questions is whenever you start out, get rid of fractions as fast as you can. So here I have everything being divided by x plus 1. The opposite of dividing by that is timesing by that. And again, when you times it by it as a group, so they get stuck together and has to go in brackets. From here, your next step is going to be to expand out the brackets. That gives me x, y plus y equals 3. And now it's just like a previous question. You're going to try and get x by itself. So opposite of plus y is minus y. And the opposite of timesing by y is going to be dividing by y. Then we're done. This is my inverse function. All I need to do now is write it down remembering to replace the y's with x's. Okay, last sample, the inverse functions. This one's slightly harder. So it's the same question, except I've changed the 3 into a 3x. So the first 2 steps are the same. We're going to replace the f of x with a y, and we're going to times both sides by x plus 1 to get rid of all fractions. And also, like before, I'm going to expand out the bracket straight away. Now, this one's slightly harder because we have 2 terms which have x's in them. Okay? And to make x equals, you have to first of all make sure there's no x's left on the other side. So if I did what I did before, and minus the y and then divided by this y, I would then get it looking like this, which technically is x equals, but we call this an implicit function because x shouldn't equal something else in terms of x. That's kind of a bad way to do it. So what we're going to do, before we can get x by itself, we need to get all the x's on one side and everything else on the other side. So I'm basically going to swap the places of this 3x and a y. If they both change side, they're also both going to change sign. So I now have xy minus 3x equals minus y. Now, we don't want x to appear once. The way we can get around this is we can factorize. So if I say x brackets y minus 3, now I only have x appearing once, and it's more similar to our previous examples. We have x being times by something, times by this group here, and the opposite of timesing by that is going to be dividing by that. So x will be minus y over y minus 3. And we're done, we've got x equals, so therefore my inverse function is going to be this, replacing the y's with x's. Okay, that was inverse functions. So again, it can go from quite straightforward and really nice to quite a lot of inverse algebra there. Last topic is we've also asked to solve equations with functions. So again, the first example is really straightforward. We're given a function, we want to solve it equal to 50. All that means is because f of x is this, we know that 4x plus 7 equals 50, and we're going to solve that equation. So opposite of plus 7 is minus 7, opposite of times by 4 is divide by 4. That doesn't go nicely, so we just leave it as a top-heavy fraction. Okay, same idea, slightly harder again, this time using a fraction. So I know f of x, we are told, is 2 over x minus 1, and that equals 7. And we're then going to solve it. And these steps, to be fair, are roughly the same as what we do when we change the subject. First, we're going to times by my denominator. Next, I'm going to expand the brackets out, and then get x by itself. So opposite of minus 7 is plus 7. Opposite of times by 7 is divide by 7. So that there, x is 9 over 7. And that's fine, leave it as a mixed number again. Okay, 2 more hard examples, both of these involving quadratic terms. So here we need to work out fg of x. So let's work that out first. So fg of x is going to be f of x minus 3, because that's what g of x equals. We then plug that into f of x. So we now have x minus 3 squared plus 3 lots of x minus 3. Okay, first we can do is just expand all this stuff out. So first term we can expand out using the grid method, x minus 3, x minus 3. Going through that, that will give you x squared minus 6x plus 9. So that's my first term there. My second term, expanding that out, will give me 3x minus 9. Okay, grouping that together, we are now going to have x squared minus 3x. So let's change that, change the minus to a plus. And so this was fg of x, and we want to solve this equal to f of x. So this now needs to equal f of x. And right at the start we are told f of x is x squared plus 3x, which gives us this fairly weird looking equation. Let's go through and solve it. So first step, we have x squared and x squared. They're both going to cancel out. We're then left with minus 3x equals 3x. That's like an ordinary equation. We're going to get all the x's on one side, everything else on the other side. So opposite of minus 3x is plus 3x, which means 0 equals 6x now, add another 3x to this 3x, therefore x is 0. Okay, one more hard example using that same idea. So this layout's coming like increasingly popular in the new GCSEs. We basically work out both compound functions and then solve them equal to each other. So fg of x, that's going to be f of x squared. Plugging that into f, we just have 2x squared minus 4. So that was surprisingly nice. We're then going to work out gf of x. That's going to be g of 2x minus 4. With a plus 2x here. G of x says just square whatever's inside my brackets. So g of 2x minus 4 will be 2x minus 4 all squared. Again, including the plus 2x. Next, we need to expand this out. So for that, again, we can use the grid method. 2x minus 4, 2x minus 4. 2x times 2x will give me 4x squared. I've then got minus 8x and minus 8x and a plus 16. So I've got 4x squared minus 16x plus 16. So therefore this is now going to equal, I've got minus 16x, I'm also plus in 2x. So that will just become minus 14x, and the plus 6x doesn't change. And again, we know from before that that has to be solved equal to 2x squared minus 4. So that was my first step. What I've done there is I've worked out what each function equals. I'm going to simplify my right hand side a bit. Now we have this equation to solve. Okay, this is going to be an ordinary quadratic, because that's my biggest power of x. The way you solve a quadratic is you must make it equal to 0 first. So take away the 2x squared from both sides. Means this 4x squared becomes a 2x squared. The 14x doesn't change. And the opposite of minus 4 is plus 4. So this plus 16 becomes a plus 20. We're now going to solve this equation. Before we factorize it, the first one to check is, can I halve everything, or can I divide by a common factor? In this case I can. So let's halve the whole equation. So now 0 equals x squared minus 7x plus 10. For these questions, if it says give your answer to 3 significant figures or give your answer as a square root, that means you must use a quadratic formula. Here, because we're not told that, at no point did it say it will be a nasty decimal or a square root or anything, we know it must factorize. Okay, so again, you look for these slight hints in your questions. So you want two numbers that times to give us plus 10 and add to give us minus 7. That is just minus 2 and minus 5. That equals 0. So we would therefore solve each bracket equal to 0, which gives me my two solutions. X is either 2 or x is 5. And then after all that work, we're finally done. So again, these questions are becoming a lot more common in GCSEs nowadays. So make sure you're okay with those steps. And again, like 9 times out of 10 I've seen it, you end up solving some quadratic at the end. Okay, that's it. That's basically all the main things you need to know for functions. Hope that was useful, and thanks for listening.